Hello, welcome to 9.3, Graphing with Holes. So, all we're doing for this section is just expanding on what we've been doing with graphing our functions and taking it a step further and graphing with our holes, which our holes are just three things. Okay, so a hole is just a spot in the graph that isn't plotted. It's not on the graph anymore. It comes from a canceled factor. And to find the coordinate of your hole, you set the factor equal to 0 to find coordinate. And then the third thing we need to know, you plot the point as an open circle. Okay? Because it's a hole, it's not really a part of your graph. Okay? So, as we look at this first problem, our first step would be to see if we can factor anything. So, we can factor the bottom to, it's a difference of squares. So we have our x plus 4 on the top. The bottom factors to x plus 4 and x minus 4. So if you could see here, we have an x plus 4 on the top and an x plus 4 on the bottom. So those can cancel. So then that would leave us with a 1 on the top, because when you divide out what you have on the top, or on the bottom too, you have a placeholder of 1. So that would be 1 over x minus 4. So this is going to be our new equation. So in this case, our hole is going to be where the x plus 4 is. But we'll get to that in a second. So let's figure out all the different parts of our graph. So our vertical asymptote, that's when we set our denominator equal to 0, and we're going to focus on our new graph. So we're going to, or not a new graph, our new equation. So I'll make sure I have the y equals. Okay, so we want to set our x minus 4 equal to 0, so that would give us an x equals 4 as our vertical asymptote. To find our horizontal asymptote, we look at the degree, and if you notice, we have a higher degree on the bottom. So that means we have a horizontal asymptote of y equals 0. If you didn't remember that from yesterday's video, you can take those notes out to refer to them. And to find our x-intercept, we just set our numerator equal to 0. So looking at our equation here, we'll have 0 equals 1. We don't have any variables here, and this isn't a true statement. So that means we have 0, or known, x-intercepts. And then to find our y-intercepts, we just set x equal to 0. So as we do that, that would give us 1 over 0 minus 4. So that would give us a negative 1/4. So what point this gives us is a 0, and negative 1/4 is negative 0.25. So from here, I'm going to plot everything that I know about my graph. So I know my vertical asymptote is at 4. So x equals 4. My horizontal asymptote's at y equals 0. My x-intercepts, I don't have any, and my y-intercepts is at 0, negative 0.25. So 0, negative 0.25, so roughly about there. Okay. So then we're gonna have to figure out our domain and our range. So looking at this, what x values can we not have? And since this is an asymptote, we can have all real numbers, but we can't have an x value of 4. And to look at our range, we're looking at our y values. And so looking what y values can we not have? Oh, we have an asymptote here. So that means we can have any number, but we can't have a y value of 0. And now for our holes, as I said above, we need to set the canceled factor equal to 0 to find the coordinate. And that's what we need to do to figure out where our hole is on our graph. And so in this case, our canceled factor is x plus 4. So I'm going to take my x plus 4, set it equal to 0, and solve for my x. So I get x equals negative 4. So then from here, what I have to do is take this point and say, okay, well, x equals negative 4, that is where my hole in my graph is going to be. Because at x equals negative 4, if I plug this in, I get a denominator of 0, but when this cancels, it's actually not even there. It's not even a part of our graph. So that's why we have to find this spot. Because when we go to graph, we have to make sure we have an open circle there. Okay, so we have to plug this into our new equation to see, well, this point isn't on our original equation, but it's going to be somewhere on our graph, so or where our hole would be. So we plug in our negative 4, so we get 1 over negative 4 minus 4, which gives us a negative 1 over 8. So this tells us our hole is at the point negative 4, that's our x, and our y is negative 1 over 8, which is negative 0.125. So right on our graph, we could plot this. So negative 4, negative 1.25, and that is a open circle. Was that a very good open circle? Open circle. Make sure you draw this as an open circle, okay? Because it's not actually on our graph. So, as we're at this point, now let's try to figure out the 3 points to the left of our asymptote and 3 points to the right of our asymptote. And to do this, we'll have to get our calculator out. So take a second, get your calculator out. Okay, so we have our calculators. Let's plug in our graph into our y equals. Don't forget your parentheses around your numerator and your denominator. So we have this plugged in. Make sure your window is at Z standard, so zoom 6. So this is what our graph looks like. As we're looking at this, we have a asymptote clearly here at 4, so we're good. Oh, and I should say we're plugging in our original equation so that way we can see our holes. And see, just in case we made a mistake in our factoring and canceling, we always graph our original equation. Okay? So then looking at this, I'm going to zoom in so that we can see what our hole looks like on the graph. It'll look the exact same, but I just want to show you. So if we go to our window, we know our hole is going to be in between our x values of 3 and 5. So I'm going to make my x min be negative 5, my y value be negative 3. And we know the y value is in between our negative 1 and 1, so I'm going to make my y min be negative 1, my y max be 1. And this should help us to see, looking at this graph, we have this tiny little hole right here. It's just one little pixel. It looks like it's missing. That's our hole. So that's just to show you how our hole isn't really part of our graph. That's why it's so important that we have it be an open circle. Okay, so let's zoom back out. So here we have our graph. Let's get 3 points to the left and to the right of our asymptote. So let's go to our table. So second graph. And our vertical asymptote is at 4. So let's get 3 points to the left. So that'd be our x value of 3. So at 3, we have the point negative 1. At 2, we have the point negative 0.5. And at 1, we have the point negative 0.3. And then 3 points to the right. So that's going to be our values of 5, 6, and 7. So let's scroll down. So we have our values of 5, 1, 6.5, and 7, 0.3. So let's plot these points. We have 3, negative 1, 2, negative 0.5, 1, 0.3. And let's connect our points. And remember to not draw your line through the hole. And then we continue down. We're getting really close to these asymptotes, but we do not cross them. And let's plot 3 points to the right. So 5, 1, 6.5, and 7.3. And the same thing, get really close, but you don't cross your asymptotes. Okay? And one other thing that we have to add. So since we have this hole here, that means we don't have an x value at this point. So that means for our domain, we have to add our x value of -4 because we don't, or what x can't be -4 because we have a hole there. And in the same way, we have a y value of -0.125 that we can't have because that's also where our hole is. So make sure to fill in your hole in your domain and range of what x and y cannot be. Okay? So let's move on to this next problem. So again, first step is factoring. But before we do that, I'm going to switch this problem up a little bit. So this is actually going to be a minus sign. And I'm going to rewrite the denominator to be x squared minus 2x minus 8. Alrighty. So looking at this, we have to factor. So what is our GCF from the top? So we can factor out a 2x, and that gives us an x minus 4. And then our denominator, that would be which numbers multiply to be -8, add to be -2. Well, that is a x minus 4 and an x plus 2. So looking at this, we can cancel out a x minus 4 from our top and bottom. So that would leave us with a 2x over x plus 2. So this is our new equation. So from our new equation, let's figure out all the different pieces. So our vertical asymptote, we set our denominator equal to 0. So x plus 2 equals 0. So x equals -2. Our horizontal asymptote, we look at our degree. So in this case, we have the same degree on the top and bottom. When we have the same degree, we look at our coefficients. So the ratio of our coefficients, so that's 2 over 1. So that would give us a y value of 2. X-intercepts, we set our numerator equal to 0. So 0 equals 2x. So that would be an x value of 0. So that gives you the 0.00. And then our y-intercept, we set our x equal to 0, so that would be 0 over 0 plus 2. So that's also 0, so you get the 0.00. Then let's graph everything that we know so far. So vertical asymptote of -2, and horizontal asymptote of 2. And we have our x-intercept at 0, 0, and our y-intercept, so those are the same points. So now let's look at our domain. So what x values can we not have? Well, we can have all of them except our x value at -2. Can't have that. And same with our range. We can have all of them. All of our y values except our y value of 2. And then for our holes, remember we set our canceled factor equal to 0. And we solve, so we get x equals 4. Then we take this 4 and we plug it into our factored or simplified equation. So that would be 2 times 4 all over 4 plus 2, which is 8 over 6, which that would give us the 0.4, 1.3. So then from here, we know then that we can't have a x value of 4 and we can't have an x value of 1.3. So then from here I want you to graph this and find 3 points to the left and 3 points to the right. Alright, so once we get our 3 points to the left, 3 points to the right, I plotted those, and as I connect them, make sure they don't touch your asymptotes. And make sure you plot your hole. It's an open circle. Do not draw your line through your hole. Ooh, and we can have more than one whole. So our canceled factor was actually canceled factors. So we can have more than one. So same rules apply if we cancel out more than one. It's just two different points or multiple depending on how many canceled factors we have. Try the one on the back and bring it to class tomorrow. See you.